Hi everyone, thanks for joining us. Welcome to Are We All on the Same Page? Let's Fix That, presented by Luis Mineiro. My name is Spoons, or Daniel Spoonhauer. I'm the CTO at Lightstep. I'll be moderating today. So today's talk is part of 99% Visible DevOps Reliability, a series of talks about building and operating reliable software applications. I'll talk about what's coming up next in our series at the end of the presentation. Before we get started, a couple of things. Today's talk is being recorded, and we'll share a link of the recording with everyone that signed up for the session. And speaking of sign up, if you would like to hear about future talks, please head over to 99percentdevops.com. If you're tweeting about today's talk, which I encourage everyone to do, we'd love it if you'd use the hashtag 99%visible. So for the plan for today is, after I finish my introduction, I'll hand things over to Luis. And I budgeted, I think, 30 or 40 minutes for his talk, and we'll save some time at the end to answer questions. So please use Zoom's Q&A feature. It's down over here somewhere, I think, to submit questions along the way, and then we'll go through those at the end. Before we get started, though, I wanted to first take a minute to thank our sponsors. 99% Visible is sponsored by Lightstep, Blameless, CodeFresh, Rollbar, and Noble9. We all know that DevOps is a lot more than tools, but tools like these can be effective ways of kickstarting new DevOps practices within your organization. Because really, ultimately, DevOps is about your teams and the people on them. And really, one of the most important things is that we understand where knowledge within those teams lives, right? Who are experts in what systems? Who are the owners of what systems? And we can use tools to help support that, right? And that kind of brings me to the subject of today's presentation. So I'd like to introduce today's speaker. Today's talk is by Luis Mineiro. Luis has worked on a number of different areas as a software engineer, including DevOps, system administration, networking, and more. Luis has been with Zalando since 2013, working with approximately 200 engineering teams, increasing the observability and reliability of the Zalando e-commerce platform. And he's currently heading their site reliability engineering. So I'm excited to see what he has to share today. Again, we'll have some time at the end to answer questions, so please use the Q&A feature. And with that, over to you, Luis.
Thank you so much, Daniel. I hope that everyone can hear me. And I'm also a bit excited and thankful for folks probably from very distant time zones, probably joining so early. It's mid-afternoon where I am, so it's probably easier for me. So thank you so much for participating in today's talk. As Daniel already mentioned, I'm going to be talking about this thing that we titled, Are We All on the Same Page? And let's fix that. During this talk, I hope it gets more clear why we should fix it. Before we jump into the actual content of the talk, there is a bit of context which is around my employer, which I'd like to share with you. Zalando is Europe's leading online platform for fashion and lifestyle. Basically, big fashion e-commerce platform, more than 34 million active customers, more than 2,500 brands, and all of this today is resulting in gross merchandise volume sales of around 8.2 billion euros last year. So all of that money means a lot of traffic. All of that traffic means a large-scale platform. Large-scale platform translates to very large distributed system, many teams. In total, it's above 14,000 employees in Europe. And all of this scale suggests exactly a complex distributed system. This is a part of this talk. And I think this context is relevant because you're going to be talking about monitoring, alerting. And the way that I prefer to approach this is to start with a story. And the story goes like, a while ago, maybe a long time ago, we used to run monoliths. I think this is what many of us were lucky enough to run and operate at one point of our careers. And this is relevant for this talk. And why this is relevant? Because when we were operating those monoliths, these things, they handled every request and response would be the entire responsibility of this single process, this single monolith. There were minor evolutions of this basic model, sometimes for redundancy, standbys, things like that, increasing availability. It's not so relevant though. The important part when we were doing things like that was that monoliths were really simple. They were really easy to reason about, and they were easy to monitor. At this time, this was also when we had the ops and dev silos. So these things were sort of going hand in hand. I'm admittedly trying to simplify here, but I think this is a pretty fair description. The ops people focus on managing the hardware, if it's working or not, if it has power, eventually check if the monolith process was up. Just being up meant that it was healthy. And eventually the devs would focus on monitoring the requests and the responses, eventually augmenting that with measuring the response times. And that was pretty much it. It was fairly simple, siloed but simple. On the other hand, I guess everyone in the audience would agree that this approach had its own share of problems, particularly as business started to grow. And this approach was actually hindering businesses to continue to grow and keep up with the growth of the business. And it was preventing them to scale further. So I don't think this is going to be a surprise, but how does everyone think that the industry react to these problems? How did we deal with the monolith problems? Well, we solved it. We came up with things like this, and we created microservices, and everyone started adopting them, and a lot of people actually today jumped straight into this. This choice of this image is very deliberate to also demonstrate how complex it can get. This is not going to be another talk about microservices, but this context of this complexity, I think it's very important when it comes to the monitoring, and in particular, when it comes to alerting. So I'm going to try with a less complex example, still complex though. This is a typical business operation for e-commerce websites, not even particular for fashion. I think pretty much every e-commerce website out there would have a pretty similar architecture. And every e-commerce website hopefully will have an operation that allows its customers to place an order. This is at the end of the typical browsing, choosing, adding to the cart, and then checking out. So this is probably the last step. One could argue even one of the most important ones when it comes to running an e-commerce platform. To fulfill this business operation, it's pretty common that the number of involved microservices could be similar to this diagram. For example, at Zalando, we have north of 60 microservices involved in this particular business operation, and some of them are also some so-called legacy ones. So there is a lot of different things with different maturities involved in this particular operation, and this is just one of the many operations. So if you are trying to compare this for your own organization, it may actually look too complex, or maybe to some of you, it may actually sound too simple. Okay, your mileage might vary here, but it's also not so important because I think at the end, hopefully, this example is good enough to demonstrate what this talk is about. Now, we just talked about monitoring monoliths, and let's try to adapt and see how are we monitoring these architectures. These are modern architectures that we are running today. How are we monitoring? Or how do I think that we are monitoring these things? At least in my experience, we did a couple of interesting things as an industry. First, we came up with new roles and gave them names, fancy names. Some of them call themselves DevOps engineers. Some of them call them SREs. The name is actually not the important part. We could be calling them cupcake fairies. It doesn't really matter. What matters is that the way that we monitor these new complex distributed systems did not change much. We still check if boxes are alive, pods are up or not, if EC2 instances are up or not. We still keep checking those things and get alerted on them. We still check if certain processes, or maybe absolutely all of them, are responsive. We may check if microservice A is successful, and we may also measure individual microservices latency to check if they are fast enough. So when it comes to monitoring, my personal experience has been that we're just monitoring a distributed monolith. we're doing pretty much the same that we did in the past in the monolith era, just in a more complex and difficult way. So I just mentioned monitoring, but alerting is not necessarily monitoring. So now I would like to continue this example, trying to demonstrate how I've seen alerting being done in this setup. So what do we think happens when, in this particular diagram, for example, the accounting service, which is there at the top, bottom right, is going through an outage? What I've seen almost always happening is that dozens, if not hundreds, of alerts come up. This is very typical, especially when different teams are responsible for those different microservices, but this is not exclusive. We can even have a single team owning 10 of those services, and they will most probably end up creating alerts on each one of them, paging alerts no less. So when this effect happens, I call this the Christmas tree effect, because it also has a lot of blinking lights. It's always the same, except I'm pretty sure the happiness levels are very different, and I'm very sure no one is getting any presents. So this approach almost always leads to an excessive number of paging alerts and will result in alert fatigue. And this is the core of this talk. Why is this completely unnecessary? Why is this unnecessary and unhealthy? Only one of these teams can actually do something about it. The fact that we are paging all of them is unnecessary, just causes confusion. And from my own personal experience, leads to the first 10 minutes of the recovery time, different teams trying to figure out what's happening, where is this coming from? In this particular case, the team that is responsible for the accounting service is the one with the biggest insights and the ability to do something about it. Most probably will be able to recover it in a couple of minutes. So this is why this is problematic and results in alert fatigue. The alternative to this is not new, actually. Alerting on symptoms is something that the industry already figured out quite a while ago. And it is accepted that we should rather alert on symptoms, and we should be doing that. But this is really just theory. And why I think this is also difficult, I want to advance now the example on what if we were doing this alerting on symptoms. So if we are now adopting what the industry already taught us that is a better practice, we would be looking for a place where we could have a good signal to noise ratio. In this particular case, it is closest possible to the customer itself, in a place that we feel comfortable with the measurements and in a place that we can control it. And in this particular example there, in front of the checkout service would be potentially a good place to capture the signal. In this particular place, we can measure very simple things like we do almost everywhere else, like the latency and the errors. We could measure it here and use that as a good service level objective, for example, and we could capture those SLIs. Now, taking this particular example where the alerting rule would be created there in front of the checkout service, what would happen now if the same accounting service, which is again in the bottom right, is going through an outage? What would happen this time around? The alert that we created in that place would be triggered. Just one. This is much, much better than the previous approach on every single service, on everything that they do, being triggering alerts. So this looks much, much better. I guess everyone would agree. Could there be anything wrong with this approach, though? I think with the next example, this will be clearer. Now, a different service is having an outage. What would happen with the exact same example, with the same alerting rule based on the symptom, if the payment service is going through an outage? No surprise, the exact same alert would be up. And the same team, the owner of the alert rule, would be the one getting the paging alert for each and every possible failure in the distributed system. Any of those services that could bubble up failure to the place order operation would page the exact same team. One could argue that it's slightly better, because at least now we are only burning out one team instead of all of them. But this is far from ideal. This is not something that we should aspire to, and I think we could do better. And this is exactly this pivoting to this problem. Up until recently, to the best of my knowledge, has not been properly addressed. Alerting on all of the layers of the distributed system is not healthy. It leads to alert fatigue. Alerting on the symptoms can actually result on bombing the team owning the client-facing service, and none of these are good enough. Coincidentally, when we were developing a solution for this last year, there was a Twitter thread by Charity exactly following up on this question from Jacob Scott, where they were saying the microservice organization where teams own specific components and services of a distributed production system, who is responsible for triage, debugging, routing of issues that don't present with a clear owner? And how do they not hate their lives? This resonated so much with me. And this was exactly, it's surprising why this doesn't come so often. Why wasn't the industry collectively trying to do something about this? And I think everyone honestly struggles to deal with this. Everyone that I've talked to in conferences, including those where this talk was already part of the program, everyone that I've talked to, they really struggle to go through this problem. And obviously, it's not a coincidence. This is exactly what this talk is about, adaptive paging. Adaptive paging was the name that we gave to this thing. It's basically an alert handler that leverages the causality from tracing and OpenTracing semantic conventions to page the team closest to the problem. So this is the shortest description of what this thing that we created is about. And I want to share with all of you basically how it works. Basically how it works is that from a single alerting rule, a set of heuristics can be applied to identify at the alert delivery time the most probable root cause and only page the respective team instead of the alert owner. And before I actually dive into the details how all of this works, I also want to describe the main ingredients for this. One of them is OpenTracing and its semantic conventions. This is just a quick introduction about distributed tracing, in particular OpenTracing. OpenTracing, for those that may not be familiar, is a set of vendor-neutral APIs and code instrumentation standard for distributed tracing. You will be able to find out a lot more details by checking its origins, like the Dapper paper, or in its website. And some of these details are so relevant that I'm going to emphasize them here in the talk, but I will not cover in great detail all of the history and what OpenTracing is about. I do want to mention one thing that I consider relevant though. When we started this effort with distributed tracing at Zalando already back in 2017, OpenTracing was the only open standard out there to approach this. In the meantime, open sensors also appeared in the industry, and more recently, actually now OpenTelemetry is the merger of these two different standards, and OpenTelemetry is something that we are personally looking at. And for anyone starting their own journeys, I would strongly advise to start looking at OpenTelemetry, which is already in a pretty good shape to replace and provide more value than OpenTracing. Not only because it does as well as OpenTracing, but it will cover more telemetry mechanisms such as metrics and eventually logs. It doesn't change much. OpenTelemetry even offers backwards compatibility with existing OpenTracing integrations. So please consider this as a disclaimer that everything that I'm going to be talking about that follows would pretty much apply to OpenTelemetry as well, because it explores distributed tracing primitives. And some of these primitives that I want to share with you that will become relevant for how adaptive paging works are these. So the first important one is spans. Spans are named operations which record duration, and they can be enriched with tags and logs, with enriching with context. And you would usually find this every time a service does a remote procedure call. This is actually exactly what happens when you go from a monolith to a very deep distributed system. So this is an important aspect. And a trace is a collection of multiple spans, because an operation can trigger the operation and they can depend on their outcome. For example, using the place order diagram from before, the place order triggers and depends on all of the other operations. For example, the update account in the accounting service. And this is actually a very important ingredient, is one of the most important ingredients, because for that single event, for a single customer that is trying to place the order, depending on the outcome of the update account operation on the accounting service, it's super critical, because it gives us one of the most interesting properties of distributed tracing, which is causality. We can depend on it to figure out what caused what. Machines can do it as well. I also deliberately highlighted there in bold the word tags. Let me share with you what's a tag. Tag is a mostly arbitrary key-value pair where values can be strings, numbers, or booleans, and every span can have its own set of tags. As I said earlier, this is used to enrich the operation with context. You could consider this as metadata that goes along the operation with this additional context. This particular example is tagging with the error true, which suggests that this operation may have failed. And then there are some specifics here of other tags that carry their own meaning. Tags is also a very important ingredient of adaptive paging. As I mentioned earlier, this is available on both OpenTracing and OpenTelemetry tracing. So you probably saw these tags span.kind and peer.service. Some of these, we didn't come up with these names. These are actually defined by the OpenTracing semantic conventions, and those semantic conventions, they establish certain tag names and their meaning. The benefit of this thing is that they define a strong set of expectations of what machines can do while analyzing exactly tracing payload. For example, just by looking at the component tag, which by the semantic convention identifies the software package, the framework, the library, or module that generate the associated span, for example, the checkout service, we can already identify this service, for example. The error tag, which expects a Boolean value, true, would mean that the operation represented by the span has failed. And there are way more. So in this particular slide, I included a link to the OpenTracing semantic conventions. The OpenTelemetry semantic conventions are even richer than these. I'm quite happy that some of these things have been preserved. So the migration path also is not expected to be too costly. But the bottom line is that machines can be programmed to look at certain presence of certain tags, and depending on their values, derive something. And this is this concrete example here, where we actually start seeing all of this shaping together, because tracing also gives us implicitly some golden signals, like latency and throughput. By instrumenting every single operation in your distributed system, you will implicitly get latency measurement and the throughput of the operations per second. Using the semantic conventions of error true, we also get the error rate, for example, where every time a span has the error tag set to true. So I just mentioned these 4 golden signals in case some folks are not so familiar with that. The 4 golden signals of monitoring are latency, traffic, errors, and saturation. So if you can only measure 4 metrics of your user-facing system, focus on these 4. They are great for alerting, actually. For the next example, we're going to focus on one concrete signal, alerting on the error rate. Assume that you have configured an alert for your place order operation, which has an SLO of 99.9 success rate, 3 nines success rate. A typical way to catch these would be some sort of criteria like in the component checkout service and the operation place order. This would capture exactly that throughput, and this operation place order would report its success rate or error rate if you want. It's a good place to measure the signal, the symptom, and create an alert rule. The specifics how you create the alert itself, this would depend on which tool you would be using. There are many open source and commercial solutions for it. So I'm going to leave that outside of the scope of this talk. But how you define the rule, it would be tool specific. As I mentioned, adaptive page is an alert handler. It should be on the receiving end of that. So when that is triggered, you could hand over to adaptive paging as a webhook, the delivery itself. So we're going to focus on that part alone. This webhook, the first thing that it would do is to collect exemplars. Examples would be a set of traces that are representative of the situation, and that's the data that the webhook should use for the analysis. This can already be done by your tool, by your distributed tracing tool. For example, I'm very familiar with Lightstep, for example. Lightstep already includes a set of exemplars in the alerting payload, but any other tool will probably provide you an API to go and query for operations that match a certain criteria within a certain time span that could be helpful as well to collect some of those examples. And this is an important aspect because instead of just looking at one individual operation, you want to collect a good set of exemplars that you want to look at. And what this webhook, the adaptive paging, would do with each one of those for each given trace, starting at the span where the silo has been defined, in our case was the place order operation in the checkout service. Adaptive paging walks through the trace in a recursive way. For every child span, its tags and the respective values are checked to decide which path to take. In this example, the payment gateway, the risk service, and the queue operations, they are not tagged as errors, so they don't seem important for adaptive paging. The accept order operation in the order service is tagged as an error. And this actually allows the algorithm to figure out that, I should investigate further here. So then it continues this recursive process. We repeat exactly the same. Once again, none of the operations in the order service, the stock reservation service, or the logistics service seem to have errors, which means we now look at the update account operation, the accounting service, and this one seems to be the one tagged with an error. So we continue there. Now, by looking at this particular operation, it doesn't have any child spans to continue the traversal. So the accounting service in this particular exemplar is selected as most probable root cause. We now have the operation which is identifies the probable root cause. We would do this across all of the exemplars and eventually stack rank them. And this is actually something that we do. We look at them and we score them, and we take the most probable one at the end. But then we just repeat exactly the procedure that I just described. Having the operation which is identified the probable root cause, now the only thing left is to map the service to the respective team or on-call escalation that is responsible for that. So let's revisit now the previous examples to see how this would work. The signal is captured exactly the same, so we are not changing that. This is exactly where it should, because it represents the symptom. Signal to noise ratio is optimal, closest possible to the customer pain. This is definitely the right place. But now if we are using adaptive paging, what would happen if the accounting service in the bottom right is going through an outage? If we just have everything that I just described. So using adaptive paging as load handler, it would now instead page the team responsible for the accounting service, which is, by the way, the one that can do something about it. What would happen once again with adaptive paging if our second example was if the payment service is going through an outage? Once again, in this example, the rule is exactly the same. We're not changing anything. The SLO is the same. It represents the success of placing orders, but the alert handler will take care of it instead, identifying that the payment service seems to be the closest root cause. And this is the team responsible for this, most probably a different one, is the one that can do something about it and should receive the page. This is great, because now we're no longer page bombing anyone. We're not page bombing the owner of the alerting rule. We don't have the Christmas tree. It's very promising. I have to agree with Charity. We also think this is a smart way to solve this particular problem. We actually been collecting a lot of successes in our organization doing this, but I would not be completely honest if I didn't share some of the challenge that we faced with this, even leaving aside some of the organizational change and the cultural change that is required for large organizations to actually migrate into this approach. So I want to share with you some of the more technical challenges of the implementation. The detection algorithm itself, you can adopt many different strategies. I pretty much shared still pretty much what today our algorithm does. It uses only a couple of heuristics that are very easy to reason about. When we have an outcome of a paging decision, we record all of those decisions and we look at them, and we can very quickly reason and explain to teams and folks that have been paged why they were the ones that were selected. And this almost always results in, we can improve instrumentation for the system itself to be more accurate. One of these cases is where multiple child spans are tagged as errors. We ended up realizing that even if we come up with 2 different services having the same score from the analysis, paging 2 is still better than paging everyone else, or paging the owner that cannot do anything else. So even facing that ambiguity, we already find ourselves in a relatively better situation. The other one is the peer.service tag. This is one that is defined in the OpenTracing semantic conventions, which is very helpful when my target team, the team that operates the service that I'm calling, didn't bother to instrument it yet, which actually prevents adaptive paging to continue the analysis of the trace. But adaptive paging respects the peer.service tag, which may indicate the receiving service name. And even if that one is not instrumented, we can still try to resolve which team is on call for that target service. This ended up working as a very good incentive for those teams to go and instrument it, because most times they're also not the ones that were causing the problem. They were transitively in the middle of something that failed up further upstream. So this is a pretty good incentive to get more instrumentation done. Last but not least is mapping services to on-call escalations. This actually requires something that I didn't mention. We happen to have an application registry where every single service that we have in production is registered, and attached to that, we obviously have this field of the on-call escalation that is looking after that. So we have this mapping done there, but I understand that maybe this is not something that exists on every organization, and it seems to be a relevant piece of information. I know that some organizations actually include that on each and every operation. They have a tag that represents the on-call escalation to be paged. That's also a solution. I share the example of tracing root causes for errors when the error rate is. It doesn't mean that this shouldn't work for latency as well. Now, the difference is that figuring out the possible root cause that contributes to an increase in latency, it's a challenge of its own. It's not as straightforward as tracing where does the nested error come from. You can also not just look at the longest span in the trace, because probably that is the one that is very stable, just being slow all the time. So it didn't cause the variation that triggered the rule. So doing this exactly the same for latency, it's a different challenge that we are still not doing today, mostly because typically the jump from slow, so slow, failing, it's very typical, and the errors are capturing all of those as well. We also started looking at some interesting work excellent work from LinkedIn, a paper from 2013, Monitor Rank. And this would actually fit very nicely with this. It actually looks at data, structured data such as this one, and does the ranking and the scoring exactly in order to figure out what is the biggest contributor to a certain effect. So we also looked at that. Something that we did more recently already this year is that we managed to implement the multi-window, multi-bun rate alerting strategy. For those that haven't read the SRE workbook, this is actually described there in great detail. And some great folks from my team did some simulations with different alerting strategies, different time series behaviors, and they figured exactly which alerting strategy would be ideal, maximizing some relevant KPIs, such as the precision, the recall period. So there are a couple of interesting metrics that allows us to measure which one is ideal. And we were able to prove as well that multi-window rule augmented it already using that, with an unexpected benefits at the time that we were building these things, which was today for us to create an alerting rule, we basically just need a formal SLO for the symptom, and then all of those alerting parameters are derived automatically from that SLO. It just works out of the box. So these were actually some great additions that we continue to work in adaptive paging, and I'm really, really proud of the work that has been done there so far. I guess as a conclusion, I personally think that observability, which is this word that has been around for quite a while, folks have been talking about that, I've been talking about that, still has ways to go. There's still a lot there to be done. There's still a lot of popular things that end up being perceived as the holy grail on how we should monitor and observe systems, and sometimes that's not the case. It leads to this behavior that truly burns out folks, and that is something that personally affects me. So it's very easy to confuse as well monitoring and alerting. For me, they are definitely not exactly the same thing. Monitoring is something different, alerting is something definitely different. I'm hoping that with this talk, this contributes to improve the alerting situation overall for the audience, for anyone else that you may end up bumping into, and share these thoughts, because I believe particularly can be very, very helpful with paging alerts that burn out humans and make our lives better. So before we segue into the Q&A, which will be your Q&A, I wanted to share this slide because we're always hiring. If any of you feels interested in working in such interesting topics, such as this one, in any of the teams inside reliability engineering at Zalando, please take the time to scan this. You will find at least one job ad there that I would like to invite you to consider. And with that, before we hand over to your questions and answers, I'm going to end with my own question. Are we all on the same page? Back to you, Danny.
Awesome. Thanks, Luis. This was great. Yeah, I was on a team once that was exactly that, that team at the very top of the stack, and we were sort of a human routing system for getting the right team awake and able to help us do things. Yeah, one of the questions that I was thinking about a little bit, like you had this Christmas tree for a particular operation, right? So, placing an order can kind of have this explosion across services. But I was wondering if you had any ideas about how to address a kind of different sort of Christmas tree, which is like when, say, what was it, that queuing system that you have, say that thing, which is probably, part of many different business operations, right? Say there's an issue there, you could have sort of a different kind of explosion. I don't know if you've had thoughts or experience around how to handle that sort of thing.
Let me try to clarify. Are you specifically asking about the asynchronous parts with the message buses when they're involved?
I wasn't necessarily thinking about more just like, say your message bus has a bunch of errors that could affect not just placing orders, but, getting recommendations, updating cart, like all kinds of things could break in that moment. So you might still end up alerting a lot of different people, or maybe the same team over and over and over again. And that's sort of, I wondered if you had thoughts about that.
Yeah, indeed, we do, because that is actually relatively much easier after the fact, because then it becomes a relatively simple deduplication effort that you can do. I'm not going to lie and say that we have it all figured out. We actually thought about it, and we reserved an SLO on the alerting latency, on the time that we reserve to deliver the alert, which allows us to buffer for a while the delivery. Because when that thing happens in a short period, you can park it there for a bit. And if other things end up resulting on the same root cause affecting other operations, you just need to add to the existing one that, oh, this is also being affected. So the placeholder is being affected, view product details is being affected, something else is being affected, but you are still the root cause.
Yeah, yeah. Okay, cool. That makes sense. Thanks. Another question, you talked a bit about the scoring. I wondered if you could say a bit more there, and how maybe that's evolved over time even, and how you think about how to...
Yeah, we can. It's still very simple. I actually appreciate simple things, and it's no trouble to share exactly how we do it. Please, if I make a mistake, if someone from my team is in the call and I make a mistake, please bear with me, because the last time that I personally checked those things was a long time ago. But we defined a threshold of certainty. So when we analyze the exemplars, at least 80% of the analysis outcome needs to be higher than 80% to give us the certainty that that is the probable root cause. So we just defined a threshold. As soon as we are scoring, we score each one of them that we considered a possible root cause. Mm-hmm. And then we go through the next trace. We do the same thing. We keep adding score, which means at the end of analyzing all of the exemplars, we have n services, each one with a score. The highest one wins, but it needs to be higher than 80%, or else it's too ambiguous and we feel like less than that, the algorithm needs to be improved. From experience, typically it's higher than 80%, typically. There have been occasions where it's lower than that. And this is what I mentioned during the talk, that we usually find out that we should improve instrumentation. There is actually ambiguity in poor instrumentation.
Yep, yep, okay, cool. Let's see. Another question, how hard is it to measure the operational improvements? And what do you measure? Is it MTTR, mean time to problem identification, developer satisfaction, retention, right?
Excellent. This is really great question. So the first KPI that we looked at, because this is the one that we almost immediately understood, and the data suggested that this would improve the TTR. I actually share with you the anecdotal episode of myself participating in some of these incidents. And the first 10, 20 minutes were honestly teams talking to each other. What's going on? Where is this coming from? Bear in mind, the team that has an error is there as well. But this is not clear in that moment when everyone got a page. People are just there still figuring out, because they lack this easy visual hint that tracing can give you, which is there, goes there, and it fails there. So I cannot say much more great things about the visualization of tracing and the causality property. So I was in those sessions spending those 10 to 20 minutes, completely wasted time to recovery. They were completely wasted. And something such as adaptive paging can pretty much eliminate that part. So definitely one metric, which is very useful for your management and for such an investment, would be exactly time to recover, which will translate to money, guaranteed, and availability. We actually continue to think about this. So some of the things that we are suggesting are actually pretty interesting and resonate as well. So we are considering, we haven't nailed this down yet, but preliminary, I can share with you that we are coming up with an on-call health score or a fatigue score. It has many contributing factors. Some of them are obviously how often folks are paged, how often they are paged outside of office time when you cannot afford to have a follow the sun strategy. So we are including some of these indicators and deriving a fatigue score. We haven't yet established the causality relationship to retention or attrition, if you want, but this is something that then we intend to derive. One hint though, because we actually did this exercise already, we want to make that connection, and this is where aggregates are not a great approach. You actually may be burning out 2 or 3 individuals, which will happen. Some teams are much, much worse than the rest. So don't look at averages. We made that mistake. Go look at concrete individuals, measure those fatigue scores by individual, because one is enough to pay attention to.
Yeah. Are you telling me that I should be looking at P99? Is that the answer here?
Look at each and every one of them.
Yeah. Okay. Cool. Thanks. Another question: as your monitoring matures, do your SRE or reliability team members have a seat at the table with the teams that are designing or architecting new services?
Yes, this is also a great question. Thank you so much for putting it like that, because effectively, organizations can deploy SRE in many different ways. Okay, and I've personally seen it done in many different ways, and almost no one else is Google, and almost no one else can do what Google does. And I actually don't think that Google does the best job possible, because they have so many thousands of SREs that can basically burn them out. So I'm not going into more detail there, but
even within Google, I can say that Google is not the right thing sometimes.
exactly. But that being said, how the organizations deploy SRE can be very different. So I can share with you how it works at Zalando in hope that may help. We do get a seat at the table. We do not have a blocking mandate, such, for example, Google SRE would have. We don't block releases per se. We don't have that mandate. We are a central team we are effectively, my teams are not on call for the services out there that the teams are deploying. We actually support them in order to do a good job. Some of that support, specifically answer your question, designing architecture, is something that we do with a group of principal engineers in the organization. We do production and readiness reviews. So this is our opportunity exactly to be there for bigger launches, risky things that we include that in part of our service offering, and that's where we get that seat at the table. Most often, the outcome of those production and reviews is exactly identifying fragilities in the system, lack of observability, pretty common, how we can further augment the observability instrumentation in order to understand better when things happen, bad things happen. So this is where we have a great leverage point there to make the overall systems better. But an important detail which is related to our deployment model is we actually don't have a mandate. And we're also not on call for foreign things.
Right. Yeah. Okay.
I hope that answers the question.
I think so. Yeah. Yeah, maybe we have time for one or maybe two more questions. One I was thinking about was, I mean, you talked about like the registry, right? Which I think is a great, that I could probably talk about that for a long time. But like for an organization that doesn't have that yet, or maybe an organization that's just getting started with something like that, like what are kind of first steps that you would take to start to deploy something like this adaptive paging?
Well, to my big surprise, when I engage with other folks in conferences and other situations, meetups, to my surprise, even rolling out distributed tracing is something that is really widespread at this point in the industry. It should be very clear that something like adaptive paging only works if you have distributed tracing. So this will actually be the first requirement that I understood can be very difficult, can be a very lengthy process to get a good chunk of the distributed system instrumented with enough quality so that you can actually capture that signal. So this would be my short answer. First, get the basics done in place, distributed tracing. Then adaptive paging today, implementing this algorithm is something that should not take anyone more than a couple of weeks, honestly. 1 or 2 engineers. This was honestly the case. We did a proof of concept thing for 1 or 2 weeks. We had the idea and we just wanted to do it very quickly to see if that would actually work. And after a couple of weeks, we had this POC in front of our colleagues with their pages, actually paging them in a simulated environment, actually demonstrating that it worked. Only then we went to think about, wait, this can be something. We can productize this. We can build this. We can improve our lives using this. So we actually did it in that approach.
Okay, cool. All right, I think last question for today. You said sometimes the word observability can be defined in different ways, and it's not the holy grail by itself, right? So what are some developments kind of coming up that you're most excited about?
Very interesting question, which hopefully no one, there will be many different opinions about this. So I'm going to start with a disclaimer that this is my opinion, okay?
Sure.
I'm not trying to sell another holy grail. It is my opinion. based on my personal experience of things that I've seen work, and more importantly, not work. Okay. And this is probably the most interesting part. It's very hard for individuals that invested a lot of time of their lives trying to do something to acknowledge that this is no longer working. Okay, I'm going to refer exactly to a concrete part of this talk. Not a single engineer that I personally talk to has any pleasure or enjoys the Christmas tree effect, but they still do it. Okay, so there are a lot of factors here that are harder to explain than my skill set allows me to understand in depth. There are some cultural aspects to it, definitely. There is FOMO involved, there are a bunch of different things. But I think observability, without coming up with a hardcore definition, which charity is always aiming at, and I really enjoy sometimes jumping in and say, yeah, that and that. Even recently we discussed that monitoring is use and observability is red. For those that are missing, use and red are the different monitoring strategies, request driven and infrastructure saturation driven. But let's not digress there, because I'm going to jump to your concrete question. New developments that I'm personally more excited about: distributed tracing as ubiquitous. The causality property is the most important ingredient to achieve observability. I honestly do not think that just go with isolated metrics, snapshots here and there, anyone will be able to just deliver it. You can get signal, but you cannot get the causality property. The causality property is the most fundamental thing that you can get. And I have absolutely no problem in stating that distributed tracing is the enabler towards observability, because this causality property can be explored in many different ways. What I'm most excited about after that is how some big players in the industry are converging to that, and by already being in a certain part of the journey around distributed tracing, and how that journey is converging with the service level objectives journey. So 1 month ago, give or take, the talk by Alex was really great. I also participated, and it's great to see how we are evolving in this approach to SLOs. We've actually started this back in 2016. We did many, many things wrong. We have no problem admitting it. But as we evolved our observability journey, we also started seeing the SLO journey converging and making way more sense, because things that I mentioned here of go look for the symptom, go look for a rule, an alert rule that would work out well. And I basically shared exactly what we've done already with multi-window, multi-bun rate, derived completely automated from that symptom based solely on its formal SLO. This solves a lot of things. So last but not least, these are two things that I'm really, really personally excited about. Not many people are spearheading this yet, but I've seen happening in industry with some vendors and some folks from the community actually driving this forward. That leaves me personally very excited.
Awesome. Yeah, that's great. I think that's all the time we have for questions today. So I wanted to thank everyone who joined us live, and thanks to all of you who took the time to watch the recording. I also want to give a huge thanks to Luis for a great talk. I really enjoyed it. I'm glad that you were here to give it. I wanted to say you've been watching 99% Visible DevOps Reliability. It's a series of talks about building and operating reliable software applications. If you have any thoughts about this talk, you can find Luis on Twitter at VoidMaze. You can find me at save_spoons. And before you leave, I wanted to let everyone know that we've got the next talk lined up, which I'm really excited about. It's going to be in about a month. And Cindy Sridharan is going to be talking, I think, about zero downtime deployments. So check that out. That's October 22nd, and that's going to be a little bit later in the morning for me. And as always, we'll record that talk as well. So for those of you that it's not the right time, you can always catch the recording afterward. If you signed up for today's talk, you'll get an email about how to register for that talk soon. And if not, head over to 99percentdevops.com. 99% Visible is brought to you by Lightstep, Blameless, CodeFresh, Rollbar, and Noble9. Thanks again, everyone, and we'll talk to you soon.